Why did Isaac Newton and Gottfried Leibniz invent calculus at the exact same time, completely independently while totally unaware of each other?
Right. It's a huge historical mystery.
It really is. And why did Alexander Graham Bell and Elisha Gray both file a patent for the telephone on the exact same day?
Yeah, the exact same day.
And then you've got these completely isolated groups of monkeys on different islands who suddenly, start watching their food in the ocean on the exact same week. Welcome to today's deep dive. We have a really fascinating stack of sources spanning biology, theoretical physics, and philosophy today.
It's a really diverse stack.
Definitely. And our mission today is to explore this mind-bending question about you. Are our brains just these lonely, isolated processors locked inside our skulls? Or are they actually more like the smartphone or computer you're using to listen to this right now?
Like a terminal.
Exactly. A terminal connected to a massive, invisible biological internet. So today, we are unpacking a theory called morphic resonance to see if humanity might be standing on the edge of a critical, new evolutionary threshold.
Which is a huge concept to wrap your head around.
It is, because the historical record is just full of these rapid-fire mysteries that simply don't make statistical sense if human minds are isolated islands.
They really don't. When you look at the history of innovation, whether biological or technological, you constantly see these bizarre synchronized leaps.
Yeah.
What's fascinating here is the primary architect of the theory we're exploring today. He's a Cambridge-educated biologist named Rupert Sheldrake.
Right, Sheldrake.
Yeah, and he introduced this concept called morphic fields.
Mm.
Essentially, Sheldrake proposes that information in nature isn't just, learned locally and stored in the physical tissue of the brain.
Right, like on a hard drive.
Exactly.
Yeah.
Instead, information is accessed across physical boundaries without any direct mechanical communication at all.
Okay, let's unpack this. I know some of our listeners who are familiar with behavioral science are probably rolling their eyes right now because of the monkey example I just used in the intro.
Oh, the 100th monkey effect.
Yeah, the famous 100th monkey effect, where these monkeys on the Japanese island of Koshima learned to wash sweet potatoes. And supposedly, once a critical mass learned it, monkeys on completely unconnected islands just started doing it too.
Right.
But that story has been heavily criticized by mainstream primatologists. They argue the timeline was exaggerated and the monkeys might have actually swum between the islands.
Yeah, the monkey observation was definitely a bit messy.
But let's look at why Sheldrake and others argue there's still fire beneath this smoke, especially, when we look at how this is replicated in modern, highly controlled labs.
That's a really crucial distinction. The monkey thing inspired much stricter laboratory experiments, and the most notable ones were with rats navigating water mazes.
Oh, right, the Harvard study.
Exactly. Researchers like William McDougall at Harvard set up this experiment where rats had to escape a complex flooded maze. The first generation of rats made, hundreds of errors before figuring it out.
Which makes sense.
Right. But by the 30th generation, the rats were solving it almost instantly.
Wait, but couldn't you just argue that's standard genetics? They passed the spatial awareness down to their offspring, or maybe they just, left a scent trail in the water or the maze.
That is exactly what rival laboratories thought. So a lab in Scotland set out to debunk the Harvard study entirely.
Right.
They built the exact same maze. But to rule out genetics and scent trails, they bought entirely different, completely untrained rats of the exact same species.
Wait, with zero genetic relation?
Zero genetic relation to the Harvard rats. And when they dropped them in the water, those Scottish rats solved the maze at the exact same accelerated speed as the 30th generation Harvard rats.
Wow.
Yeah. They inherited the knowledge without inheriting the genetics or sharing the physical space.
That's wild. And the sources show this isn't just a biological phenomenon with animals either. It actually extends into chemistry, specifically the physical building blocks of matter.
Yeah, this part is really mind-blowing.
There is this documented phenomenon in chemistry related to crystallization. When scientists synthesize a brand new chemical compound in a lab, getting it to crystallize for the very first time is notoriously difficult.
Right, because the atoms literally don't know how to arrange themselves into a lattice yet.
Exactly. It can take months, sometimes years of manipulating temperature and pressure just to force a new compound to crystallize.
Precisely. From a physics standpoint, those atoms have millions of potential geometric configurations they could settle into. They're just searching for a stable state.
Right.
But the bizarre part is what happens after that first successful crystallization.
Yeah.
Once a laboratory in, say, New York manages to crystallize a new compound, suddenly a laboratory in Tokyo finds it significantly easier to crystallize that exact same substance.
Which is crazy.
It really is. And it gets easier and faster for every subsequent lab globally.
Okay, let's unpack the mechanics of that. It's sort of like folding a crisp, brand new piece of thick paper.
Okay, I like that analogy.
Yeah, the very first time you try to make the crease, it takes effort, alignment, precision. The paper resists you. But once that crease is established, the paper naturally wants to fold along that exact line every single time.
It finds the path of least resistance.
Right. It seems like nature has this universal copy-paste function. But how does the crease travel from a lab in New York to a lab in Tokyo? Like, if the universe is copy-pasting information, where exactly is the hard drive?
So to explain the physical mechanism, Sheldrake uses a principle he calls formative causation.
Formative causation.
Right. He argues that we need a fundamental shift in how we view physics. We need to stop thinking of nature as being governed by fixed, immutable laws and start thinking of it as being governed by habits.
Habits. That's a very different word.
Exactly. Every physical system in thermodynamics wants to find the state of lowest energy, the path of least resistance.
Yeah.
So the first time a new behavior or physical form occurs successfully, it leaves this invisible pathway in the universe's memory.
No, wait. When you say universe's memory, I feel like a lot of people listening might immediately think of Carl Jung's concept of the collective unconscious.
Oh, sure. That's a common comparison.
How does formative causation differ from that?
Well, Jung's collective unconscious is a brilliant concept, but it is strictly psychological. I mean, it deals with human archetypes, shared mythology, and the symbolic content of the mind.
Right.
Sheldrake's morphic fields are infinitely broader and distinctly physical. They aren't just thoughts. They're the literal structural blueprints organizing the physical world.
Oh, wow.
Yeah, they dictate how proteins fold in a cell, how a baby's DNA knows to form the precise shape of a human hand, and even how animal migrations are perfectly coordinated.
And the most important distinction in the sources here is that this information doesn't just, float in a physical cloud above our heads. It operates non-locally.
Correct. Non-locality is this concept from quantum mechanics, where two particles can interact and share information instantaneously, completely, regardless of the physical distance between them.
No signal traveling through the air.
Exactly. Sheldrake suggests the brain operates much more like a radio receiver. When you listen to a jazz station, the band isn't hiding inside the plastic box on your kitchen counter.
Right.
And the music isn't stored on a hard drive inside the speaker. The radio is just tuning its antenna to a frequency that already exists everywhere at once.
And our brains are the antennas. I mean, the biological structure of our complex neural networks literally acts like a fractal antenna array.
Yeah, that's the geometry of it.
Right, because in physics, a fractal geometry where the smallest part of a structure reflects the complex shape of the whole is the absolute most efficient physical shape for catching and processing dense data packets.
It really is.
But this brings up a massive divide in the scientific community regarding what this field is actually made of. Some researchers argue this network is simply an electromagnetic field, pointing out that human hearts and brains generate measurable toroidal fields.
Yes. So a toroidal field is it's essentially this continuous donut-shaped energy field that loops around and through the body.
Okay.
The theory there is that all our individual electromagnetic, or EM, fields merge in the atmosphere to create this giant global data cloud.
But Sheldrake pushes back on the electromagnetic theory because of the distance issue, right?
Exactly, because EM fields are bound by the inverse square law. I mean, think of the campfire.
Okay.
The further you walk away from the fire, the exponentially colder you get. A magnetic field weakens drastically over distance. But morphic resonance ignores distance entirely.
Like the rats.
Right. The rat in Scotland gets the data just as fast as the rat in the next cage over. Because of this, Sheldrake aligns morphic fields closer to what quantum physicists call the zero-point field.
Let's define that because, it sounds like sci-fi jargon, but it's a very real concept in quantum mechanics.
It really is. If you take a vacuum chamber, pump out every single particle of gas, and shield it from all heat and light, the remaining space isn't actually empty.
Right.
It is this boiling soup of microscopic quantum fluctuations. Even in a complete vacuum, there is a baseline of energy woven into the very fabric of space-time itself.
Wow.
That is the zero-point field, and Sheldrake argues this ubiquitous field is the actual medium that holds the universe's memory.
Okay, wait. I have to challenge this premise. If our brains are fractal antennas and we are constantly transmitting and receiving data from a quantum space-time field 24/7, like an app constantly refreshing its feed in the background, Why aren't we just completely crushed by the noise? Like, if I am biologically connected to 8 billion people, why don't I hear 8 billion thoughts competing for my attention right now?
That's a great question, and it comes down to the evolutionary role of the brain. In this framework, the brain isn't just a receiver. It is a highly evolved biological filter.
A filter?
Yeah. The novelist, Aldous Huxley, once described the brain as a reducing valve. If we were consciously aware of the entire cosmic field, we just wouldn't be able to function. We'd go insane.
That makes sense.
So the brain filters out the overwhelming noise of the universe and only brings into our conscious awareness the specific frequencies that we personally resonate with.
Ah, so it only downloads the updates that are relevant to our specific hardware and survival.
Exactly. It lets in data related to our deep family ties, our intense personal focuses, or immediate threats.
Which naturally leads to the next question. If our brains are highly evolved filters, actively blocking out the noise of 8 billion people, what actually makes it through the filter? Like, what does a relevant data download look like for the listener on a normal Tuesday morning?
Well, you see it most clearly when the filter allows in the frequencies of the groups we belong to.
Like a crowd.
Exactly. Think about a massive crowd in a stadium suddenly acting in perfect, spontaneous unison, or a flock of starlings murmuring in the sky. When thousands of birds turn flawlessly as a single organism, they're reacting in under 100 milliseconds.
Wow, that fast.
Yeah. That wave of movement propagates through the flock faster than biological reaction time even allows. They aren't just looking at the bird next to them and reacting.
They are moving within the exact same morphic field.
Precisely.
And it explains that universally recognized, deeply unsettling feeling of being stared at. The sources dive into Sheldrake's famous studies on this phenomenon.
Right, everyone knows that feeling.
Yeah, you're sitting in a crowded coffee shop reading a book, you suddenly get a chill, you turn around, and someone is staring directly at the back of your head. According to morphic resonance, that isn't paranoia or coincidence.
No, it's an evolutionary survival mechanism. The person staring at you is focusing their attention, which creates a literal physical pressure and intention wave in the local morphic field. Your brain antenna picks up that shift in the field, and your amygdala processes the threat before your visual cortex even has time to scan the room. It entirely bypasses your conscious logical thought.
And we apparently share this deep morphic connection with our pets, too. I mean, the famous Pam Smart experiment, which Sheldrake detailed in his research regarding dogs knowing when their owners are coming home.
Oh yeah, it's one of the most rigorously tested aspects of his entire theory. They set up these synchronized cameras to monitor a dog at home and the owner miles away.
Right.
They proved that the dog would go wait at the front door at the exact moment the owner intended to return home. Not when they physically started walking to the car, but the exact moment the decision was made.
Wait, but how did they rule out the dog just, hearing the specific rumble of the owner's car engine from a mile away, or smelling them on the wind? Dogs have incredibly sensitive biological instruments.
They controls for all of that. They randomized the return times, having a third party page the owner at an unpredictable hour so the owner couldn't subconsciously stick to a routine. They forced the owners to take completely unfamiliar vehicles, like random taxis or bicycles, to rule out the sound of a specific engine. They even accounted for wind direction. None of the variables mattered.
That is wild.
The dog still went to the window the exact second the owner formed the intention to return. The intention altered the shared field between them.
Here's where it gets really interesting. So what we call culture or tradition is basically just humanity's morphic habit. Even a baby's reflex to nurse, or our own biological blueprint for how DNA arranges a hand or an eye, is essentially downloaded from the species' morphic blueprint.
That's the implication, yeah.
So if our brains are receivers tuning into this field, and our intentions actively alter the field around us, what happens when we intentionally try to change the dial? Like, can we hack the field to change our own reality?
We can. And honestly, many people already do, though they use different vocabularies for it.
What do you mean?
Take the pop culture concept of the law of attraction. It's often packaged as mysticism or magic. But through the lens of morphic fields, it is simply the physics of sympathetic resonance.
Sympathetic resonance, like tuning a guitar.
Exactly. If you have two acoustic guitars sitting on opposite sides of a room, and you strike the heavy E string on one guitar, the E string on the untouched guitar across the room will begin to visibly vibrate and hum on its own.
Right.
They're in sympathetic resonance. So if your brain is constantly outputting a frequency of fear or lack or victimhood, You are tuning your biological antenna to resonate with all the matching data packets in the global morphic field.
Oh, wow.
And the field naturally organizes those matching scenarios right into your physical reality.
But here is the friction point. When someone decides to change their tune-like, they decide to raise their frequency, improve their life, start a new business, or get healthier, they suddenly face all these attacks.
Yeah, that happens a lot.
They get dragged down by negative people out of nowhere. If they are broadcasting a better frequency, why does the field suddenly seem to attack them?
That is a phenomenon known as field resistance or homeostasis. Remember that in thermodynamics, a system wants to maintain its lowest energy state.
The habit.
Right. A morphic field, whether it's the dynamic of your immediate family or society at large, wants to maintain the status quo. Change requires massive amounts of energy. So when you try to change, the system instinctively resists.
It's the classic crab bucket analogy.
Exactly. When you have a bucket of crabs and one tries to climb out to freedom, the others will instinctively reach up and pull it back down. It isn't malicious. The system is just trying to preserve its established habit.
It's basically a stress test of your new frequency. But the sources also show that we don't have to fight the field alone. We can actively shape it together through what they call constructive interference.
Yes, in wave physics, when two waves of the exact same frequency merge, they don't just add together, they amplify each other exponentially. When groups of people come together with a shared focus, through collective rituals, mass prayer, or synchronized meditation, they create a massive wave that writes a deep, new habit into the morphic field.
The Maharishi effect. This is one of the most fascinating studies in the stack. In the summer of 1993, researchers gathered 4,000 practitioners of transcendental meditation in Washington, D.C.
Right, I remember reading about this.
The chief of police went on record saying that the only thing that could drop the violent crime rate in the city by 20% would be 2 feet of snow in July. But as the group meditated together over the course of the summer, creating constructive interference, the rate of violent crime dropped by a staggering 23.3%.
Yeah, is incredible.
That isolated group effectively acted like a giant water filter, cleaning the city's shared morphic water supply for everyone else.
They fundamentally changed the baseline frequency of the local environment, which really proves that our internal states have external, measurable consequences.
It means your mental hygiene is actually a collective responsibility. Sitting alone in your room, stewing in anger or resentment, isn't just a private, isolated emotion.
No, it's not.
You aren't just hurting yourself. You are dropping poison directly into the shared water supply. We are all playing notes in the same global symphony.
Which brings us to the inevitable controversy here. If this theory explains so much of our interconnected reality and has experimental data backing it up, why isn't this being taught as standard science in every university?
Oh, we have to talk about the ban. The 2013 TEDx Whitechapel controversy. Rupert Sheldrake gave a talk titled The Science Delusion, and the scientific establishment had an absolute meltdown.
They really did.
TED literally branded his talk as pseudoscience and hid the video entirely.
Yeah, they scrubbed it. Sheldrake used that platform to directly challenge the dogmas of modern science. He argued that mainstream science has stopped being an open-minded method of inquiry and has calcified into a strict materialist belief system. He listed these unprovable dogmas that govern modern research, like the assumption that nature is just a mechanical machine, the belief that matter is entirely unconscious, and the absolute certainty that memory only exists inside the physical tissue of the brain.
But, I have to push back on Sheldrake's framing here just a bit. Is modern science really a materialist religion? Or is the scientific method just demanding reproducible, undeniable proof that Sheldrake's invisible fields exist outside of just, statistical anomalies?
That's a fair point.
It's a heavy claim to say science is acting like a religion just because they want harder evidence.
It's a very fair critique of Sheldrake, and the scientific method absolutely demands rigorous proof. The issue, however, was the establishment's refusal to even debate the data.
Right.
Instead of replicating the dog experiments or the crystallization test to prove him wrong, the scientific board at TED simply demanded the video be erased from public view.
Which is concerning.
And if we connect this to the bigger picture, you can understand the institutional panic. If the mind can directly affect matter non-locally, and if information can travel without physical mediums, it threatens the foundational models of massive industries.
Like pharmaceuticals and energy.
Exactly. It decentralizes power in a way that is chaotic for the established economic order.
So what does this all mean? The irony is just beautiful.